All right, welcome back. It's Friday afternoon, so I expect that delays will not be popular, so I think we should get right back to work for this last session about practical approaches to data management. Obviously, as it's stated in the program, it should be Elena Cortés Ruiz who were chairing this session. I'm not Elena. I'm Jan Dalsin Sørensen. I'm head of digital preservation at the Danish National Archives and also chair of the DLM Forum, and I will be chairing this last session. The first presentation will be by Seth van Hooland from the Université Libre de Bruxelles. And the title of the presentation is Machine Learning and Information Governance, a Happy Marriage. Seth.
Thank you. So perhaps let me start with a warning. I'm actually a library and information science person trapped into the body of someone who's doing records management research, but which probably can explain my unbound love for controlled vocabularies, which will play an important part in this presentation. But so for those of you who actually assisted to the wonderful visit yesterday of the Royal Pavilion, actually here you see a red panda, and in a way it made me think of George IV when he saw for the first time his forced wife when he asked to just have a brandy and then basically ran away. But so as a way, I also wanted to use the red panda as a metaphor for like the archival and the records management community. We have a kind of a fixed or relatively fixed body of standards, of policies. We have our retention lists, we have our filing plans, but I would say already since the 1970s, the 1980s, with expert systems, automation regularly has popped up, and a lot of kind of hopes have always been expressed, but in a way there's always also been some angst to what extent, for example, especially now, machine learning could be considered in a way like a Nile perch. So here on this picture you see this very happy fisherman holding a Nile perch. It's the ecologically the most dangerous fish species, in the sense that it was artificially introduced in Lake Victoria towards the end of the 90s, and it gradually ate up all of the other fishes. So in a way, is machine learning here to kind of to eat up all of our retention lists, our filing plans, and basically also us as individuals? So Mette and James already have talked or have given wonderful presentations about machine learning, what you can expect from it, what not. And within this presentation, I basically would like to ask the question, is it a forced marriage, or in some extent, can we go towards a happy marriage? So for a long time, within nature, scientists thought that penguins were monogamic, but actually it was discovered then that they only stay together for 1 or 2 years in order to bring up the children, and then they part ways, the parents, and they look for a different partner. So also what is quite important within this whole rapidly evolving technological setting, I would say potentially we could go towards a happy marriage, but as in real life, it's a lot of hard work, and it could end up more being a kind of a serial monogamic context. But so first of all, so you all know about Alan Turing test, and yesterday a new paradigm was launched by Mr. Lapin. But so if we just kind of come back to his question, well, let's say, can we rely on a computer to categorize emails into 2 buckets, and mainly identifying emails which have to be put into the bucket with emails with business value when someone gets hit by a double-decker? So automation traditionally has already been around for a couple of decades, and I would say in order to come up with a solution for the James Lapin test, you basically have 2 options. So first of all, you can rely on rules. Rules have been here since, I would say, almost the 1970s, 1980s. For those of you who have heard about expert systems, it was to some way revamped, for example, in some of the artificial intelligence work in the 1980s, 90s, and then was revalorized in the context of the semantic web. But the whole, I would say, concept of using rules is that you formalize or you take an element of the empirical world, like here the water bottle, and you try to make an abstraction of its properties. It has a volume, it has a weight, it has a price. And so you build, it's based on this assumption that you can make an abstraction of reality, and based on that kind of formalization, you can trigger rules. I would say the most simple example, which probably most of you know, is the capstone approach. So if you say, starting from a certain hierarchical position or a management position in an organization, we'll just automatically consider all of the email of that individual as being of business value, and it will be automatically declared as records. I would say that's kind of the traditional rules approach towards automation, which is valuable in the sense that it's cheap and it's very highly predictable. You know how it works. On the other hand, the big disadvantages are that you're going to, in a lot of contexts, massively create records, which involves all sorts of litigation or issues with protection of personal data. And also, if you go towards a more complex rule system, it just costs a lot of money to actually model all of these different events and actions in a fine-grained way. But the whole assumption is that you fully understand the reality that you're dealing with. What James and Mette have talked about is like the new paradigm based on statistics, machine learning. But both of them talked about the supervised approach. So the supervised approach is actually you're going to use humans to train a machine. So you take 2 buckets or 4 or 5 or 10 and you throw during a certain amount of periods documents into the right bucket, and then once you have a corpus which is big enough, the machine can learn. But what is not sufficiently underlined, but I think Mette in a way talked about it, this whole process of actually feeding intelligence into the machine can be extremely time consuming. Later on, actually this slide talks about it. So I don't know if someone of open text is here in the room, but here on the left-hand side, you see the kind of the interface which open texts provides to work with auto-classification. So they've built quite a nice fluid interface which helps you as a records manager to actually select a sample and to train your algorithm on it. But from a very kind of a marketing perspective, they present it as being something extremely simple, which you can do in half a day. But in reality, things are a lot more complex. And also, OpenText, or this module, is horrendously expensive. So for those of you who are considering that type of option, there's a brilliant paper by André Vallino describing, which was published in Records Management Journal last year, who describes in all tedious detail all of the tremendous amount of work which you have to go through in order to set up or to train an algorithm. So for those of you who are interested in that topic, I would say that's definitely one of the better papers to read. But so all of this talks about supervised machine learning. And I would just like to talk a little bit about another family of machine learning, which is unsupervised. And so in order to make things a little bit more understandable or concrete, I've used here a case study I've been working with my doctoral students and in collaboration with the team of the European Commission archives. So here on the left-hand side, you see an example of the so-called COM files. So the COM files are one of the most unique archival holdings of the European Commission, I would say even on the level of the European institutions, because they span a period from the end of the 1950s until the beginning of the 1990s. So every week, the SecGen didn't exist, but it was the body playing the role of the Secrétariat Général. Every week, organized meetings in which the discussion and the implementation of, for example, regulations were being noted down. And so you have this tremendous, I would say, within this corpus, the individual documents aren't terribly sexy or original for a historian, but the value is really in the aggregate, as you can explore, for example, how ecological concerns in agricultural development were gradually more and more of a topic. This is the type of research question which you can ask to this type of corpus. But the big problem is that you only have minimal level metadata. And so here, this whole corpus was scanned and OCR'd. And so in order to attach or to extract more value and semantics out of this corpus, so with my research team, we've applied two distinct techniques of unsupervised machine learning to actually create an automated connection with Eurovoc. And so just a little word about the corpus. So the PDF dump which we obtained, PDF files, was almost 140 gigabytes. Then we converted that into TXT files. What is quite peculiar and also very interesting from a historical and from a computational linguistics point of view is that every document is actually present in one of the official languages of the European Union. So we have French, Dutch, German, Italian, Danish, English, and Greek. And so these translations were human-made, so they are of high quality. On the other hand, there, as I said, we only have tombstone metadata, so basically you are aware of the year and the title of the document, but for the rest you can do a full-text search. But as a historian, for example, if you launch a query on agriculture, you just get such a massive number of documents sent to you that it's quite hard to actually to make sense of that gigantic volume of data. And so I don't know how many of you know the figure of Franco Moretti. He's a bit the rock star of the digital humanities. He wrote this brilliant little book, Graphs, Maps, Trees. And so he's a literary scholar, but one of the first ones to actually start using computational linguistics or statistics to say, we've been studying too long the little canon of the Shakespeares and the Lord Byrons. Let's actually take all of the literature which has been published, also the bad literature or the pulp, in order to really get a global understanding of how literature as a form evolved through time by using computational means. And so one of the ideas here of making sense of the COM corpus is to try to apply similar methods. And so the first thing which we did was to apply topic modeling. Topic modeling, I'm sure that some of you have already worked with it. It's extremely popular now in the digital humanities realm. But so what topic modeling basically does, it attributes I would say it will, from a statistic point of view, look what groups of terms appear together in documents. And so, for example, here in this, it's an iconic example of David Bly, who is the person who developed LDA, a specific topic modeling algorithm. So you can see here, based on this article, the algorithm actually extracts 4 topics, but each topic is a cluster of terms. So you see, for example, in the bottom, computer, data, something else which I can't read, data, number, computer. So those that's a finite set of terms which is clustered together. But then the big disadvantage of this technique of topic modeling is then that you still need a human being to actually make sense or to sit down for a minute and to think, okay, what is the logical link between brain, neuron, nerve, or data, number, computer? So as a human being, you still have to put a label, a post-it on those different groups of topics. But again, in literature and in history, for example, my students in Brussels, they've been using this technique, for example, to explore very large volumes of non-structured text, like the cable gates, etc., or vast bulks of non-structured text published on the web. So it's valuable, but the big drawback is that you still have to kind of attach the label in an intellectual way. And so here, it's not a very pretty slide, but what you see are the first results which we obtained by running topic modeling on the corpus of the Commission. And so probably can't read it very well, but you see actually here you have 50 topics, and for each topic you then have 10 terms which in a way represent the topic. So for example, on the first line you have amounts, cereal, compensatory products, rice, wheat, etc., etc. So very quickly, voilà, you don't have to be a historian, you understand that this topic represents somehow regulation on the level of agricultural products and more in particular grain products. But so what we then did manually, and so I abused a little bit my doctoral students and some of the undergraduates, is to, from an intellectual perspective, attach the labels. But then one of the ideas, or one of the first, I would say, outcomes of this research project is to map documents to headings of the Eurovoc thesaurus, so that over time we could make a visualization with having the kind of the Eurovoc skeleton from the end of the 1950s until the 1990s, and with a timeline like a little Christmas tree with flashing light bulbs that we can see actually starting from the 1960s or 70s, those headings become a lot more popular. So for example, or to see if after Chernobyl, nuclear safety starts popping up. So that is kind of a little bit the rationale behind all of this. But voila, it's extremely tiresome to spend days and weeks to attach those labels to the groups of terms. And so that's when Matthias, one of my doctoral students, had this idea of using another family of unsupervised machine learning techniques to label. Here on the slide you just have, I won't go into detail, so other IT people have over the last 5 years used all sorts of different techniques to automatically label. But I think we use Word2Vec in a way to actually, so topic modeling is used to understand what type of subjects are treated in documents. Word2Vec simply will calculate the distance between two words. And so you can see then, for example, how the meaning of words evolves through time. And so by applying Word2Vec, again, not a very readable slide, but systematically, when we have per topic 10 terms, we use Word2Vec to, in an iterative way, filter out all of the most eccentric terms within the group to then, for example, end up with the most central key concept, which is then here meat. Voilà. Which allows us then, so for example, here in this context, the first result would then automatically map to barley. Voilà, so I understand there's quite a lot of information. I don't have the time to go into details, but I would say machine learning and archive and records management, it is a bit of a forced marriage. Seeing the gigantic overload of information we have, we can't categorize it or label it all from a kind of a human perspective. But I would say before you marry, start dating. And in my opinion, voilà, LDA and Word2Vec are kind of the best cheap and cheerful dating partners, in the sense that there are, there's a lot of documentation out there. It's not extremely simple, but if you have an IT person in your team, I'm sure that within a day they can start playing. You have all sorts of libraries, all sorts of open tools to your disposition. So in a way, very much like what was the impetus of Metastalk, I think at this stage, it's quite important as a community to just start playing with these tools. They aren't that difficult to roll out. What takes tremendous amounts of time is the evaluation process and to find out how to configure the whole system. But so for those of you who are interested more in the kind of the technical academic details, you'll find here a link to papers, also a link to the Velino and Albert's paper, and some more practical information. Voila, I think that was it. Thank you.
Thank you very much. Seth. That means that we have time for a question or two, if we have any questions.
Actually, I forgot to mention, I have to run quickly to the Brighton train station to get my Eurostar to get back to Brussels. But so if someone would have questions, or for example, with our little research group, what we need are corpora. So if you have, for example, it's kind of my ultimate dream to just get a copy of a share drive for which you almost have zero to little metadata, and then try to apply these techniques to see how in a kind of an automated way you can draw semantics from a kind of a very big volume of non-structured text. So don't hesitate to send me an email if you think that you have a corpus to play with.
I must say that we are the archive holding all the com collection.
I know the
Not
seller.
only until the 82, but until today.
Ah. But I think the scan and the OCR files.
That is ongoing.
Ah.
So it is not yet published, but it's ongoing.
Sorry. I was saying that we are the archive which is holding the COM files, and that we are in the process right now, that is the DigiCon 3 project, and we are in the process of scanning and OCR all the contents from the 80s. Yeah.
Ah, okay, perfect.
All right, thank you once again.
Pleasure.